Next speaker is Larry Cochrane from Microsoft about how to best utilize the huge amounts of data that systems like these, as well as smart meters, will be generating for us. Over to you, Larry.
Very good, thank you. It's good to see everyone. I want to make sure everyone's awake, so I want to start with a question. And the question is, how many people would connect your energy management system to the public cloud? So we have a couple takers. I think they knew where I'm headed. So one of the points I want to try to make is that some of the scenarios that are emerging, we're going to see more and more use of cloud. And I'll just give you the answer for the initial case. The initial case would be you have an energy management system. The energy management system does 200 or 500 contingencies as part of the power sequence locally, but your network is extremely large and you want to run the other 25,000 contingencies so that you make sure that you've looked across your network as thoroughly and completely as you can. The scenario would be run the contingencies in the cloud, take any important contingencies that are discovered and integrate those into your on-premise contingency analysis, and then use that for operation of the power system. So it's an initial example of how we might see cloud used in the future. I think we're going to see it in a lot of cases, and so what I want to try to do is go through some of the cases for analytics and data processing, a little bit pulled back from actual control, but still taking use of the tremendous resources that are coming with cloud. So I wanted to start with, and I think everybody's seen a diagram somewhat like this, the new ecosystem and all of the new participants in the ecosystem, both generators and consumers of electricity that impact operation of the power system. So we've seen this coming, and one of the things that we've done to help utilities and help partners is we've authored the Smart Energy Reference Architecture. And this provides guidance for how to approach dealing with a lot of the new scenarios that are emerging within the utility space. It's guidance both for utilities, product suppliers, as well as system integrators. A little bit on the Smart Energy Reference Architecture. Of course, performance-oriented, so scalability, reliability, security, availability, manageability. Are all very key. Rich holistic user experience, so exposure of information easily to a variety of consumers. So not just in the control room, but throughout the utility, and not just in the facility, but end-use consumers to crews and all information consumers in between. Energy value chain optimization, of course, this is the true nature of the business, so this is core to the utility business, so obviously that's central to the reference architecture. And then Microsoft goes to market slightly differently than some other companies. You're never going to see Microsoft, much to my chagrin, but you aren't going to see Microsoft building an energy management system or a distribution management system. You'll see us partnering closely with partners like Telvent who build these systems and deliver them. We'll build the underlying infrastructure as well as work closely with utilities on their enterprise integration, but we aren't going to deliver those direct in utility solutions. Smart connected devices. This is one of the areas where we're starting to see a ton of new information sources. So this is beyond just smart meters. A lot of people are thinking today that one of the large information sources is smart meters, and that's true. But think about all of the other instrumentation that you can add to the distribution grid that's starting to provide detailed information on voltages, transformer health, and outage information that allows you to more completely operate the power system. And then, of course, interoperability, so no reference architecture would be appropriate and complete. If didn't deal with issues like standards and interoperability and published interfaces. So that's central. So this, as a backdrop, provides great insight on how to approach using the cloud. And this gives you this eye chart gives you a detailed architecture for how we approach. And just a couple words on this, since I know that the people in the back of the room aren't going to be able to read it. This essentially includes 3 different levels of integration. One is data aggregation, so pulling information from a variety of subsystems and putting that into either an operational data store or an enterprise data warehouse. Another is business process integration, so implementing an enterprise service bus and all of the connectivity either for data exchange or for business process integration, workflow integration. And then the third is information presentment or user experience or the user interface. And then the structure of the diagram is the IT space or conventional enterprise is the inverted L on the upper right and operations on the lower left. And we believe that this pattern applies to any type of utility. So how does that relate to the cloud? Well, this provides a backdrop for how you would set up enterprise integration, and the key question is extensibility of this overall information architecture to a cloud structure. These are some of the connected systems that we'll see in the future for information exchange with utilities. It includes homeowners, and for example, if Green Pocket was implemented as a cloud service, then that would be a cloud-oriented service for providing the assessment of the profile and the controls of the equipment within your house. Demand response. Demand response is by definition a cloud application if it's over IP networks, not your metering infrastructure. Connections for electric vehicles that are through an IP network for controlling rate of charge as a portion of a virtual power plant. If you've seen any of the information on Dong Energy's virtual power plant, of course these connections, many of them are IP network-based connections for control of devices for the cloud. But where I wanted to go with this is what we're starting to see is many different sources of information, and the question is how do you approach aggregating that information and then running analytics against that information to discover embedded useful information for operation of the utility. So what is big data? We hear a lot of discussion around big data, and a lot of people think this really ties to the volume of data. But when we think about big data, we think about velocity, variety, variability, in addition to volume. So this diagram shows a little bit of those additional elements, starting with the core ERP system. Then you can see some of the things brought with web connections. And then last, the additional arena of sensors, social sentiment, social information. And so what we're talking about is bringing together information from a variety of sources. And so you think about the case, how do you figure out if you roll out a new tariff program as a utility, whether or not your consumer base liked it? And then in fact, how do you figure out if you are getting a good financial return on the tariff structure that you tried to put in place based on the number of people that are following price-sensitive load response? So you need to aggregate information from a variety of sources, and fundamentally what we're talking about is things like scraping Twitter, scraping Facebook for alerts that people have posted information, because these go viral very quickly, which means that it's all the way across the internet, exposed to a wide variety of people. So the scenario where it used to be that you would interface with customers if you were a utility through conventional means like posted paper with bills, is going to get supplanted with a whole collection of new connections to consumers and information exchange with consumers. So how do you go through the process of moving from big data to actual deriving insight to viewing? So the first step, obviously, and a lot of people think about this as the initial case, is data acquisition. So getting information from all of the various sources. And so this is more than just the notion of scanning RTUs like a SCADA system. This is aggregating information from all of the various sources and then pulling it together into a consistent platform so that you can take advantage and run analytics against it. The next step is the insight model. And this can be something as simple as standard analytics against a relational data store, such as doing meter analytics, to something as complex as a large block of unstructured data that you've pulled from the internet from social feeds, combined with your metering data, combined with your sensor data, to figure out sources of outage or figure out consumer response or consumer sentiment about the utility. And then the next question is, so what? So you've run an analysis, you've done some discovery, you've created in the new technologies a Hadoop case that was able to discover in this unstructured data some interesting, insightful piece of information. How do you operationalize that? So how do you put it into your business intelligence system so that it provides triggers for workflow or business process within the utility? And then the last step, obviously, is presentation of the information to the various people who are going to take actions, whether that's an automated connection in business process or it's graphic displays, geospatially oriented graphic displays for distribution, loading information, and analysis, for example. So this is the process that you would go through. This is a bit on the overall architecture. So it just shows the steps all the way through end to end. So the initial data acquisition from the various data sources. And then there are several different ways that you can look at the data, the inbound data. So one of the things I'm going to talk about is complex event processing. Then there's initial staging tables from raw data sources. And then you can see the various data repositories. So OSIsoft Pi, I think everybody is probably well familiar with historians. An enterprise data warehouse. Your meter management system, big data in a Hadoop's analytics store, your operational data store, your geospatial information system, and then pulling information from all of these various repositories into analytics cubes so that you can do some kind of a analysis against the data. So this shows you the overall architecture. Now you might ask the question, how does this relate to the cloud? These scenarios can be done either on-premise or in the cloud, and when we talk about the cloud, we actually have a more holistic definition. A lot of the things that you consider for a cloud are scalability, self-provisioning, pay-as-you-go. Well, we believe that private cloud and public cloud, you have the capability to do any of these scenarios in any of these form factors. So any of these deployment models we can now do in a private cloud, a public cloud, or for that matter on-premise as well. So a couple of the key points. So if you haven't, how many people have heard of Hadoop before? Okay, well, now that I've mentioned it, you'll hear about it everywhere you go. This is one of the new analytics techniques, and this is actually behind systems like Yahoo that figure out search queries and mapping the web for providing results back to you. So it's embedded in a lot of the analysis that you use every day on the web. And of course, we integrate it with our data storage products. Stream Insight, so the other piece is complex event processing, and the notion here is processing of streams of events that are coming in real time. So the normal analysis is you pull data together, you stick it in a repository, and then you write a query against it. What we're talking about is you write a query and then you play it against a stream of data to see when it triggers. So you might use this for meter event notifications so that you can strip out outages and tie those outages to your outage management system, for example. So just a couple of really quick examples to close. This shows an example of smart metering intelligence. And you probably can't read it, but this is just the master page. It includes load analysis, loss analysis, outage analysis, some other real-time insights and reports. So this is just an example of losses by region and a view of how you would approach viewing the load analysis. The other piece is how do you tie this together to your constituency? And we use a dynamic solution, CRM, as the way to implement customer-facing pages that integrate the utility with the end-use consumer and expose some of this information to customers around usage. Now, what this particular example is a demand response. So based on the results of your analysis, you've got a load deficit. How do you implement a demand response to handle the load deficit? This shows an example of a demand response program implemented in Dynamics for commercial and industrial load shedding. And then what's showing here is just all of the potential load reduction opportunities and selection of the highest priority load reduction opportunities via that pipeline. And then this shows integrated within our standard tooling, a good example being Outlook. All right, so quick pass through. Thank you, everyone. Any questions?
Let's see. Questions from the audience? Otherwise, I have one. That was just for clarification. This smart energy reference architecture, you said that's like a platform that you've built, but you will not be building applications on it yourself. You will leave that to partners. Is that correctly understood?
So the smart energy reference architecture is guidance. It's not bits. What sits behind is our products. So anybody that wants to look at it, it's at www.microsoft.com/SERA, Smart Energy Reference Architecture. It's a 130-page document. The first half of the document is challenges in the utility industry that we see and approaches on how to go about solving those challenges, like information aggregation, in a technology agnostic way. And then obviously, as you would expect from Microsoft, the second half of the document is how to cast that on a Microsoft architecture and technologies.
Fair enough. Thank you. Questions?
Okay, so for all of the people in the room, except for the three in the back who said that they would not consider connection of their EMS to the cloud, I'll be glad to have that debate offline with you, and we can talk about some of the scenarios we see coming and why I believe strongly that this is something that will be very commonplace in the future as people see it as an easy way to take advantage of very, very large architectures, very large architectural problems, or easy connectivity and storage of information. So.
Excellent. Thank you very much, Larry. Now, ladies and gentlemen, it's a coffee break, and we'll see you back here at 11 o'clock. Thank you.